There's a creature swimming in our oceans right now that was alive before the light bulb was invented, alive before the United States was founded, alive before calculus was even a concept, and it's still out there today, lurking in the deepest parts of our planet. But this isn't some tiny microorganism that technically counts as immortal, because it barely exists. This is a massive shark, an apex predator of the abyss. And what makes it truly terrifying isn't just its age, it's how it achieves this incredible longevity. Welcome to the world of deep-sea immortality, where the rules of life and death get completely rewritten. Today we're diving into the darkest corners of our oceans to uncover creatures that have essentially cracked the code of eternal life. And trust me, the methods they use are both fascinating and absolutely horrifying. But before we plunge into the abyss, make sure to subscribe to our channel because we're about to reveal secrets that most people will never know exist. Let's start with the Greenland shark, a creature so ancient it makes your grandparents look like newborns. Picture this: a 20-foot-long predator that moves through the water like it's swimming through molasses. It's completely blind, covered in what looks like stringy pasta, and moves so slowly you could literally outswim it while doing the backstroke. Yet somehow, this living fossil is one of the ocean's most successful hunters. Here's where things get really weird. Those pasta-like strings dangling from its eyes, those are parasites. Not just any parasites, but creatures that specifically target shark eyeballs and slowly devour their vision. Nearly every adult Greenland shark you'll encounter in the wild has these eye-eating passengers attached to their corneas. The scientific name is Omatocoida elongata, and they're essentially blind-making machines. Now you might think losing your sight would be a death sentence for a predator, but the Greenland shark doesn't seem to care. In the pitch-black depths where they live, being blind isn't much of a disadvantage. What's truly bizarre is that unlike other deep-sea creatures that evolved to be blind over millions of years, Greenland sharks are born with perfectly functional eyes. They only become blind after these parasites latch on during their youth. But here's what makes these sharks practically invincible. They taste absolutely terrible. And I don't mean terrible like a bad piece of fish. I mean chemically toxic, like liquid death. Their entire body is saturated with antifreeze compounds and neurotoxins that prevent their blood from freezing in the near-zero temperatures of the deep ocean. If a human ate raw Greenland shark meat, they'd experience something called shark drunk, where you lose your balance, slur your speech, and potentially die from poisoning. This natural chemical warfare makes them completely unappetizing to potential predators. Even orcas, some of the smartest hunters in the ocean, would spit out a Greenland shark immediately upon tasting it. It's like they're swimming toxic waste barrels that nothing wants to touch. So how does a blind, slow-moving, chemically poisonous shark catch anything to eat? Scientists have opened up Greenland shark stomachs and found some truly shocking contents. Fast-moving Arctic fish, giant squids, entire seals, reindeer, and in one documented case, a polar bear. Obviously, a shark that moves at 1 mile per hour isn't winning any races against seals or wrestling polar bears on ice. The leading theory is absolutely chilling. They don't chase their prey, they haunt it. Because they move so incredibly slowly, they create almost no water displacement or pressure waves. A sleeping seal can usually detect a predator approaching through vibrations in the water, but the Greenland shark is essentially invisible to these senses. Picture this nightmare scenario. You're a seal floating peacefully at the surface, and unbeknownst to you, a massive predator has been slowly drifting toward you for hours. It moves so glacially that your senses never detect its approach. Then, when it's just inches away, it suddenly expands its mouth and creates a powerful suction vacuum, inhaling you before you even wake up. Of course, not every meal comes from these stealth attacks. Much of their diet consists of scavenging dead animals that sink to the ocean floor. Those polar bears and reindeer they've found in shark stomachs were likely already dead when consumed, having drowned and drifted into the shark's path. But here's the truly mind-blowing part about these creatures. They're essentially biological time machines. The secret to their extreme longevity lies in their incredibly slow metabolism. They grow approximately 1 centimeter per year. Just 1 centimeter. This means if you encountered a 15-foot-long Greenland shark today, that individual has been growing steadily since the American Civil War. For decades, scientists struggled to determine just how old these sharks actually get. Unlike other fish, sharks don't have ear bones with growth rings like tree trunks. Their skeletons are made of cartilage, which doesn't preserve aging markers. So researchers had to get creative, and their solution involved those weird parasitic eyes. It turns out the nucleus of a shark's eye lens forms before birth and never changes throughout its entire life. It's like a time capsule locked inside their head. Using radiocarbon dating, scientists analyzed proteins in the eye lenses of captured sharks, looking for specific isotope markers left behind by nuclear bomb testing in the 1950s. If the eye proteins contained this nuclear signature, the shark had to be born after the atomic age. If they didn't, the shark was definitely older. By measuring how much carbon-14 remained in these unchanged proteins, and knowing how this isotope decays over time, scientists could work backwards to estimate the shark's age. The results were staggering. Most Greenland sharks appear capable of reaching nearly 400 years old, with upper estimates suggesting some individuals might live over 5 centuries. That means there's a shark swimming out there right now that was alive when Shakespeare was writing his plays, when the Mona Lisa was being painted, when Europeans first set foot in the Americas. Think about that for a moment. A single shark has witnessed the rise and fall of entire civilizations, the birth of the modern world, 2 world wars, the space age, and the digital revolution. Well, it didn't actually witness any of this since those parasites made it blind, but you get the incredible scope of time we're talking about. But if living for 500 years sounds like a blessing, there's a serious catch. When you live in slow motion, you also mature in slow motion. Greenland sharks don't reach sexual maturity until they're approximately 150 years old. Let that sink in. A shark born during the American Civil War is only now becoming capable of reproduction. This creates an almost impossible evolutionary challenge. Most animals need to reproduce quickly to ensure their species' survival. But Greenland sharks take longer to reach reproductive age than most civilizations last. It's an insanely risky strategy that only works because they're apex predators with virtually no natural enemies. Here's where their longevity becomes even more miraculous from a biological standpoint. Cancer is essentially a cellular lottery where bigger animals with longer lifespans should have much higher risks. The more cells you have dividing over longer periods, the greater the chance that something goes wrong and triggers tumor formation. Humans struggle to live past 100 without major health issues, so an animal living 5 times longer should theoretically be overwhelmed by cancer. But Greenland sharks have essentially solved this problem through evolution. They possess incredibly efficient tumor suppressor genes that can repair DNA damage better than almost any other vertebrate on Earth. Their cellular repair mechanisms are so advanced that scientists have found virtually no evidence of cancer in these ancient creatures, despite their extraordinary lifespans. This biological miracle allows them to wait those ridiculous 150 years before reproducing, but it creates a serious conservation problem. Because they take so long to replace themselves, Greenland shark populations can't recover quickly from human interference. If fishing operations accidentally catch these sharks as bycatch, which happens frequently, they're not just killing a fish. They're eliminating an individual that has been growing since the Victorian era and might have finally reached reproductive age. Now, here's something that will blow your mind about how these sharks experience reality. There's a biological theory suggesting that animals with extremely high metabolic rates, like hummingbirds or flies, perceive the world in slow motion. That's why you can never swat a fly with your hand. To the fly, your hand appears to be moving through molasses. Greenland sharks represent the complete opposite end of this spectrum. Their hearts beat only 5 times per minute compared to a hummingbird's 1,200 beats per minute. While we can't directly measure their brain processing speeds, it's entirely possible that these sharks perceive the world moving in fast forward. They might not subjectively feel like they've been alive for centuries because their internal sense of time is so dramatically slowed down. Their brains are also oddly small relative to their massive body size. You'd expect such large animals to have correspondingly large brains. But Greenland sharks don't need the processing power that more active predators require. Their brain is almost entirely dedicated to one function: smell. Their olfactory bulb, the brain region responsible for detecting odors, is absolutely massive. They're essentially giant swimming noses attached to stomachs, drifting through the depths and detecting rotting carrion from miles away. Assuming those eye parasites aren't causing significant pain, their lives might actually be remarkably peaceful. They're slowly drifting for centuries through an eternally dark world, eating and sleeping without the complex social interactions or territorial disputes that stress other large predators. But there's one extremely controversial theory about those eye parasites that could completely change how we view this relationship. Some scientists suspect these parasites might not actually be parasitic at all, but rather mutualistic partners. The theory suggests that in the pitch-black depths where bioluminescence is often the primary way animals locate food, these eye parasites might actually glow in the dark. If this is true, the shark would be sacrificing its already limited vision to allow these glowing creatures to attach to its head. The parasites would then act like biological fishing lures, dangling from the shark's face and attracting curious prey with their light. Fish, seeing the mysterious glow, would investigate, swimming directly into the shark's waiting mouth. The shark gets a meal, the parasite gets transportation and food scraps, and everyone wins except the unfortunate fish. We haven't proven this theory yet, but if it's accurate, the Greenland shark isn't just a blind zombie drifting aimlessly through the abyss. It's a sophisticated predator that has evolved a partnership with other organisms to overcome its physical limitations. Make sure you're subscribed to our channel because we're about to explore even more incredible deep-sea immortality secrets that will completely change how you think about life and death. For decades, scientists assumed Greenland sharks were purely Arctic creatures, trapped in the freezing waters of the far north. This limited range made them seem particularly vulnerable to human activities, since fishing operations could potentially wipe them out in their restricted habitat. But recent discoveries have completely shattered this assumption. A research vessel conducting deep-sea surveys in the tropical Caribbean made an astonishing discovery. While filming coral reefs in the deep ocean, they spotted something that shouldn't have been there. A large, gray, slow-moving shape that could only be a Greenland shark, thousands of miles from the nearest ice. It turns out these ancient predators use the deep ocean as a global highway system. Because the abyssal depths maintain near-freezing temperatures regardless of surface conditions, Greenland sharks can travel anywhere in the world by staying deep. They're likely cruising off the coasts of Florida, South America, Africa, and virtually every other continent right now. But here's the most mind-bending aspect of their global travels. Because they're completely blind and because the deep ocean is essentially a uniform environment of pitch-black, freezing water, these sharks probably have no idea where they are geographically. A shark doesn't know if it's swimming beneath the Caribbean or the Arctic Ocean. To them, the entire planet is one endless, dark, cold corridor. Imagine living for 5 centuries, traversing the entire globe, crossing under every ocean, and seeing absolutely nothing. These sharks were swimming beneath the surface when the Titanic sank overhead, but they had no awareness of the tragedy. They were alive when nuclear weapons were tested, creating the isotope markers that now help us determine their age. But they experienced none of it. They've witnessed the rise and fall of empires, the Industrial Revolution, 2 world wars, and the birth of the Internet age, all while experiencing what amounts to one incredibly long, dark Tuesday. Whether you find this existence peaceful, tragic, beautiful, or haunting, probably says something about your own relationship with time and consciousness. But there's no denying that Greenland sharks represent one of the most extreme examples of biological longevity on our planet. However, Greenland sharks aren't the only deep-sea creatures that have mastered the art of extreme longevity. The ocean depths are filled with organisms that challenge our understanding of aging and death in ways that seem almost supernatural. Consider the immortal jellyfish, Turritopsis dohrnii, which has achieved something even more remarkable than extreme longevity. It has essentially defeated death itself. When this jellyfish reaches the end of its natural life cycle or faces severe stress, it doesn't die. Instead, it reverses its aging process, transforming back into its juvenile polyp stage and beginning its life cycle all over again. This process, called transdifferentiation, allows the jellyfish to theoretically live forever by constantly resetting its biological clock. It's like having a reset button for your entire existence. While individual jellyfish can still be killed by predators, disease, or environmental factors, there's no inherent biological limit to how long they can live. Deep-sea tube worms present another fascinating case of extreme longevity. These creatures, which cluster around hydrothermal vents on the ocean floor, can live for hundreds of years despite existing in one of the most hostile environments on Earth. They survive in crushing pressure, near boiling water, and toxic chemical environments that would instantly kill most life forms. Their secret lies in their incredibly slow growth rates and efficient cellular repair mechanisms. Like Greenland sharks, they've essentially slowed down their biological processes to such an extent that aging becomes negligible. They grow so slowly that some individuals might take decades to reach full size. But this glacial pace of life allows them to persist for centuries. The glass sponge reefs of the deep Pacific represent perhaps the most extreme example of biological longevity. Some of these sponge colonies are estimated to be over 10,000 years old, making them among the oldest living organisms on Earth. Individual sponges within these colonies can live for thousands of years, continuously filtering water and growing at almost imperceptible rates. These sponges achieve their incredible lifespans through what scientists call negligible senescence, meaning they show no signs of aging-related decline even after millennia of existence. Their cells maintain the ability to repair and regenerate indefinitely, essentially making them biologically immortal under the right conditions. What's particularly remarkable about these deep-sea immortals is that they've all independently evolved similar strategies for achieving extreme longevity. Slow metabolism, efficient DNA repair, and minimal environmental stress appear to be the key factors that allow these creatures to essentially stop the aging clock. But perhaps the most intriguing aspect of deep-sea immortality is what it might teach us about our own aging processes. Scientists studying these long-lived creatures are uncovering genetic mechanisms and cellular pathways that could potentially be applied to extending human lifespan or treating age-related diseases. The tumor suppressor genes found in Greenland sharks, for example, are so efficient at preventing cancer that researchers are investigating whether similar mechanisms could be developed for human medicine. The DNA repair systems of immortal jellyfish and ancient sponges might hold keys to understanding how cellular damage accumulates over time and how it might be prevented or reversed. These discoveries are forcing scientists to reconsider fundamental assumptions about aging and death. For most of human history, we've viewed aging as an inevitable biological process, but these deep-sea creatures prove that extreme longevity and even biological immortality are possible in nature. The deep ocean environment itself plays a crucial role in enabling these extended lifespans. The extreme cold, darkness, and pressure create conditions where metabolic processes slow to a crawl. There are no seasons in the abyss, no day-night cycles, no temperature fluctuations that stress biological systems. It's an environment of remarkable stability that allows life to persist virtually unchanged for centuries or millennia. But this stability also means that deep-sea ecosystems are incredibly vulnerable to disruption. When changes do occur in the deep ocean, whether from climate change, pollution, or human activities, these slow-living creatures have no ability to adapt quickly. Their immortality becomes a liability when their environment changes faster than they can respond. The mining of deep-sea minerals, for example, poses a serious threat to these ancient communities. When mining operations destroy a sponge reef or tubeworm colony, they're not just eliminating current populations but potentially destroying organisms that have been alive for thousands of years and represent irreplaceable biological heritage. Climate change is creating additional pressures on these immortal creatures. As ocean temperatures rise and chemistry changes due to increased carbon dioxide absorption, the stable conditions that have allowed these organisms to persist for millennia are being altered. Species that have survived ice ages and mass extinction events might not survive the rapid changes humans are causing to their environment. The study of deep-sea immortality also raises profound philosophical questions about the nature of consciousness and identity. If a creature lives for 500 years, is it the same individual throughout its entire lifespan? Does continuity of consciousness require the ability to remember your past? Or is physical continuity sufficient? For organisms like the immortal jellyfish that literally reset their biological age, questions of identity become even more complex. When the jellyfish reverts to its juvenile form, does it retain any memory or experience from its previous adult phase? Are we looking at one immortal individual or a continuous cycle of death and rebirth? These questions become particularly relevant as humans begin to seriously consider the possibility of radical life extension through genetic engineering, regenerative medicine, or other technological interventions. Understanding how nature has solved the problem of aging might provide roadmaps for extending human lifespan, but it also forces us to grapple with questions about what it means to be human across extended timescales. The social and psychological implications of extreme longevity are staggering to consider. How would human relationships change if people lived for centuries? How would our concepts of career, family, and personal growth adapt to lifespans measured in hundreds rather than dozens of years? Would extended life be a blessing or a burden? Deep-sea immortals offer few answers to these questions, since most lack complex social structures or apparent self-awareness. But their existence proves that extreme longevity is biologically possible, and suggests that the fundamental limits we assume govern life and death might be more flexible than we imagine. As we continue to explore the deepest parts of our oceans, we're likely to discover even more examples of biological immortality and extreme longevity. The deep sea remains one of the least explored environments on Earth, and every expedition reveals new species and new strategies for survival in extreme conditions. These discoveries are not just academic curiosities, but potential keys to understanding some of the most fundamental questions in biology and medicine. How do we age? Why do we age? Is aging an inevitable feature of life, or is it a problem that can be solved? The answer to these questions might be swimming slowly through the dark depths of our oceans right now, in the form of ancient sharks with parasites on their eyes, immortal jellyfish that reset their biological clocks, and sponges older than human civilization. Whether we'll be able to translate these natural solutions to human biology remains an open question. But one thing is certain. The deep sea has already solved the problem of mortality in ways we're only beginning to understand. And in a world where human activities are rapidly changing every environment on Earth, protecting these ancient repositories of biological wisdom becomes more critical than ever. The immortal creatures of the deep represent living links to the distant past and potential blueprints for an extended future. They've survived ice ages, mass extinctions, and countless environmental changes by simply refusing to die. In our rapidly changing world, that might be the most valuable lesson they can teach us. The next time you look out at the ocean, remember that somewhere beneath those waves, creatures older than countries are slowly swimming through eternal darkness, carrying secrets of immortality that could reshape our understanding of life itself. They've been there longer than we can imagine, and with proper protection, they might outlive our entire species. That's both humbling and inspiring. And if you found these deep-sea secrets as fascinating as I did, make sure to subscribe and check out our next video where we'll explore even more incredible discoveries from the darkest depths of our planet.